In this video, I want to have a look at tree diagrams. So a tree diagram is a systematic way to list all the possible outcomes of a multi-stage event. So let's have a look at an example. So it says 2 coins are flipped, and then it asks us to draw a tree diagram that lists all the possible outcomes. So if we think about the first coin, so this is for A, the first coin, we have 2 options. If we flip a coin, we can get tails or we can get heads. So our first coin, we have 2 options. We have heads or tails. Then no matter what we get for our first coin, when we flip that second coin, we can either get a heads or a tails. So even if we got a heads for the first one, we can get a heads or a tails on the second one. And if we got a tails first, we can still get either a heads or a tails on the second one. So when you're drawing your tree diagram, you're trying to get every column to line up roughly, so it makes it a little bit easier to read. So then just off to the side, we can list those outcomes by reading along the branches. So we've got head and then head, or if we came up and then down, it would be heads, tails. Then we could have tails, heads, and then tails, tails. Right, so that's part A. Part B then asks us, what is the probability of tossing a head and a tail in any order? So that happens twice. We can either have a head and then a tail, or a tail and then a head. So that means that we've got a total of 2 out of our 4 outcomes. So the probability of a tail, head, or head, tail was 2 out of 4, which is equivalent to a half. So you've got a 1 in 2 chance of tossing a head and a tail in any order. Our second example tells us that a die is rolled and a coin is tossed, and it asks us to draw a table to list all the possible outcomes. So the reason we might draw a table instead is that if we tried to draw a tree diagram for this situation, for this experiment, then it might get really crowded because we've got those 6 options for a die, and then we've got 2 options for every one of those, so it's going to get really crowded. So instead we're going to draw up a table. So if we roll our die, our options are a 1, 2, 3, 4, 5, or 6. And when we write, I'll just move that one over a bit. When we toss our coin, we've got either heads or tails. So that means our options, if we draw this up, we can have a heads and a 1, heads and 2, heads and 3, and so on. And then we can have all the same, but with tails. So that's listed all our possible outcomes. So we have 12 possibilities for there. So that's part A. And part B asks us, what is the probability of rolling an even number and tossing a tail? So we need both of those things to be true. So an even number and a tail is a T2, a T4, and a T6. So that gives us a probability of a tail and even would be 3 out of 12. And then if we've got a fraction, we always simplify if we can. So that would be 1 out of 4. So that's a few examples of tree diagrams and tables.